All right, the second algorithm is very similar to the first algorithm, just slightly different. So it's also a recursive algorithm, and it makes a little bit more sense. It looks a little nicer to me, looks a little bit less random to me. But the idea is this. So again, if n equals 1, if we have one object that we're trying to enumerate a permutation of, we're done, right? There's only one way of moving one thing. Otherwise, remove each object in turn. Then prepend that object to the permutations of the other object. So what do I mean? I mean, let's go in order. We're going to remove an object, so let's remove t, our first object, so that's what it means in turn. And then we prepend, we put that at the beginning of permutations of all other objects. So in other words, we're just going to have a bunch of orderings of a bunch of things that start with t. All right. And then we'll have a bunch of orderings of a bunch of things that start with m. Then we'll have a bunch of orderings of things that start with a. Then we'll have a bunch of orderings of things that start with h. So for t now, we just need to permute all the 3 letters, which again is going to be a bunch of things that start with m. Well, 2 things that start with m. It's going to be 2 things that start with A and 2 things that start with H. Oh, I have too many. And then again, we are going to do everything that's remaining. So AH, HA, MH, HM, right? MA, AM. Okay, we do that process, right, of just doing one thing at a time. So we do all the T's. We do that same thing with all the M's. So again, there's going to be T, like a bunch, 2 T's, and then 2 A's, and then 2 H's, and we just go through this for everything. Okay, so again, this is really the same thing. We do all the T's. We do that for the first one, and then we do all the M's, and then we do all the A's, and then we do all the H's, and again, you get this growth, and we copy that for every letter. It's also recursive. Okay, it's also breaking things down into smaller pieces. And that's pretty much it. To kind of summarize these 2 videos, right, for enumerating permutations, remember that counting permutations is different from enumerating. Counting is how many there are. There are 4 factorial ways of doing this permutation right here, because there are no repeated letters. If there were repeated letters, it'd be more complicated. So there are 4 factorial ways of doing it. That's counting. Enumerating it is showing all the combinations, which can be useful for unscrambling things. Some other things that you could think about for wanting to enumerate permutations is if you're doing some kind of QA testing and you have a lot of different options for people in the order, and the order can change things, you might want to enumerate all the possible options so you can test all the possible options. That's, an example of exhaustive, different from exhaustive QA testing. You could also, this comes into play sometimes with gene sequencing when you're looking at, different ways you can order a gene. Again, you can also have partial permutations, which we'll talk about in the next video. Let's say you're making a game and you want to have some possible objectives. You want this game to be replayable. Maybe it's a board game, a card game, a video game. You want it to be replayable. So you have a bunch of events or a bunch of objectives that can happen in different orders. And you're curious about the replayability of this. Well, how many different orders can you actually have? That's going to be permutations, okay? So you can do some planning in your game development or something like that. So a few other things that you can do with this, of course. We're going to be sticking to some simple things. This is just kind of an introduction to permutations. And again, we got one more video on permutations, then we'll get new combinations after that. Let me know if you have questions. Have a good one.